James Gleick, Isaac Newton. Embark upon a fascinating journey through the life and accomplishments of Isaac Newton, one of the most influential scientists in history. Born in tumultuous 17th-century England, Newton made groundbreaking discoveries in fields like mathematics, physics, and optics. In this summary of James Gleick's Isaac Newton, you will uncover the key events of Newton's life, including the development of his three laws of motion and his rivalry with contemporaries such as Robert Hooke and Gottfried Wilhelm Leibniz. Throughout, you will witness Newton's unyielding curiosity and truly unparalleled mind, which shaped the modern world and transformed humanity's understanding of science.
Newton's seeds of genius. Born amidst political turmoil in 1642, Isaac Newton's childhood curiosity and intelligence helped him develop his revolutionary scientific ideas. At a young age, Newton displayed an insatiable curiosity, leading to the observation and measurement of the sun and moon's movements. This knowledge he applied during his education at the King's School in Grantham, where he studied languages, theology, and arithmetic. Despite expectations to pursue a rustic lifestyle, Newton knew there was a greater calling for him. On Christmas Day, 1642, Isaac Newton entered the world in Woolsthorpe, Lincolnshire, during England's most tumultuous times. The English Civil War had the Royalists, fighting for the king, pitted against the parliamentarians, who sought to curb the king's power. What's more, in this era, alchemy, magic, and mysticism dominated people's beliefs, and science-based understanding of gravity was an alien concept. Little did anyone know that this baby boy, raised in such chaotic times, would radically change humanity's understanding of the world through mathematics and empirical observation. Even as a young child, Newton exhibited signs of an undeniably curious mind. He observed and measured the movements of the sun using a string, even drawing three-dimensional sundials and geometric figures. He discovered that the moon's movements mirrored those of the sun. Newton attended the King's School in Grantham, learning Latin, Greek, Hebrew, and theology. In arithmetic class, he acquired skills in measuring areas and shapes, along with land surveying techniques. Enthusiastic about his newfound knowledge, he built lanterns, watermills, and windmills at home. However, Newton, like many adolescents, struggled to find his true purpose. His family and community assumed he would remain in the countryside, tending to the family farm. Despite these expectations, Newton felt a strong conviction that his destiny lay beyond the rural countryside. As history would unfold, his insatiable curiosity and rigor for learning would propel Isaac Newton to become one of the world's most transformative figures, whose genius continues to impact generations to this day. Unraveling Newton's journey. Isaac Newton, renowned mathematician and physicist, began his educational journey at Trinity College within Cambridge University, thanks to the support of his schoolmaster and uncle. As a curious and dedicated student, young Newton immersed himself in the world of Aristotle and more modern scientific ideas, including those of Galileo. Motion theories especially piqued his interest as the scientific community shifted toward a more empirical and measurement-focused approach. Embracing diligence, experimentation, and solitude, Newton honed his skills and his groundbreaking theories, most notably in optics, light and color. Ultimately, he concluded that everything in the world is in a perpetual state of motion or flux. Isaac Newton's academic career commenced at Cambridge University's prestigious Trinity College back in June 1661. His enrollment was made possible through the encouragement and support of both his uncle, an esteemed clergyman, and his schoolmaster at Grantham. Upon joining the college, Newton's thirst for knowledge was apparent, working tirelessly with a mere 140-page notebook, candles, ink, and a chamber pot. Trinity College's curriculum centered around Aristotle's philosophical works, teachings surrounding substances, forms, time, and motion. The institution also exposed students to modern scientific concepts, such as Galileo's ideas. Motion and our understanding of the concept evolved significantly during this time. Historically, motion was considered as much a process as a state, but Galileo altered this belief by asserting that motion should be exclusively viewed as a state. Simultaneously, science began to embrace geometry, observation, and measurement in examining and understanding nature's laws. Empirical research, along with the rise of accurate clocks, paved the path for easier, more rigorous time-based experimentation. Newton's temperament and fascination with experimentation were a perfect match for this scientific shift. In 1664, when a severe outbreak of the plague caused Cambridge University to close, Newton did not take it as an opportunity to pause his studies. He delved into his research on optics, light, and color, even carrying out a perilous experiment that entailed staring at the sun through a looking glass. Furthermore, Newton expanded his studies to integrate mathematics into motion inquiries. Through dozens of pages and numerous scenarios, Newton attempted to solve problems using motion, arriving at the conclusion that everything is in constant motion, or flux. This realization was just the beginning of the remarkable journey of one of the most influential scientists in history, playing a vital role in shaping our understanding of the physical world. Newton's journey, motion, telescope and light. As the plague relinquished its hold on society and Cambridge University reopened, Isaac Newton had already begun developing his revolutionary theory on motion. Drawing inspiration not from a fabled apple but extensive experiments, he explored the force of gravity and its effects on objects. In 1667, Newton's exceptional mathematical prowess gained him the esteemed Lucasian Chair of Mathematics, along with a laboratory at Trinity to conduct research. Here, he pioneered the first reflecting telescope which facilitated more effective observation of distant planets by increasing light exposure and reducing distortion. Newton's groundbreaking innovations caught the attention of the Royal Society, leading to the publication of his work on light and color in 1672. Challenging previous beliefs, he proposed that light comprised a spectrum of colors separated by prisms, a theory that sparked controversy and even lifelong criticism from peers, such as Robert Hooke. The struggle behind Newton's genius. Newton, known for his groundbreaking discoveries, faced considerable resistance from peers such as Robert Hooke. Their skepticism pushed Newton to refine his theories, resulting in legendary achievements like his three fundamental laws. With the support of Edmund Halley, Newton published the game-changing Principia Mathematica. Newton's brilliance was tested throughout his life by detractors, the most prominent being the intellectual Robert Hooke. Hooke dismissed Newton's theories on color and light as mere hypotheses, which deeply affected Newton. Rather than cower, Newton defended his work's mathematical basis and retreated into 2 years of isolated focus. He emerged with more findings on light, motion, and static electricity. Still, Hooke's hostility remained, even as he took on the role of Secretary of the Royal Society. Ironically, Hooke's opposition proved crucial in Newton's growth as it nudged him to delve deeper into specific fields. His relentless pressure for mathematical substantiation forced Newton to concentrate on perfecting his theory's foundations. This approach culminated in the groundbreaking 1684 paper, on the motion of bodies in orbit. In addition, Newton found a committed ally in English astronomer and mathematician Edmund Halley, who would later be known for the comet named after him. Halley's assistance went beyond moral support, as he also provided financial backing for the publication of Newton's first book in 1686, the monumental Principia Mathematica. Regarded as one of the most important mathematical works, it contains Newton's three fundamental laws, imparting crucial knowledge to generations of students. These laws include, the first, which states that objects in motion will remain in motion unless acted upon by a resisting force, the second, dictating that force begets motion, and finally, the third law, which asserts that every action spawns an equal and opposite reaction. Thanks to the support and challenges faced by Newton, his discoveries have left an indelible mark on the world of mathematics and physics. Newton's ascent to influence. Isaac Newton's rise to prominence began with his determination to make his work more accessible, paving the way for global appreciation of his mathematically verified observations. Following the death of rival Robert Hooke, Newton became head of the Royal Society, steering it away from mysticism and toward mathematically proven natural laws. Although he had yet to conclusively prove the cause of gravity, he enjoyed newfound authority as society president, facing decreasing criticism. Newton's prominence grew as his scientific work gained international recognition through advancements in printing. His influence expanded further when he was appointed Master of the Royal Mint, utilizing his mathematical prowess to create a more secure currency, attaining international acclaim and solidifying his respectability in the process. In his pursuit of sharing knowledge, Isaac Newton sought to make his complex findings easily understood, so people everywhere could benefit from his mathematically backed discoveries. Newton's leadership skills became evident when he assumed the position of Royal Society head after the death of his competitor, Robert Hooke. Under Newton's guidance, the society shifted from exploring mysticism to focusing on mathematically proving natural laws. While Newton had formulated a mathematical equation for universal gravitation, he had not yet identified its cause. Critics challenged the legitimacy of his findings, questioning whether they were rooted in mysticism. However, as the Royal Society president, Newton's authority grew, diminishing the impact of his detractors. The change of power in Britain, shifting away from a Catholic monarchy that viewed his work as controversial, helped also. Furthermore, advancements in printing technologies expanded the reach of Newton's work across Europe, increasing his recognition and support. Newton's sphere of influence continued to grow with his appointment as Master of the Royal Mint. This role showcased the growing importance of mathematics in various aspects of life, including economics and population statistics. Newton applied his knowledge to develop a more secure currency, a crucial component of a stable economic system. This prestigious position granted him international acclaim and definitively established his respectability, leading to widespread acknowledgement and appreciation of his groundbreaking ideas. Newton versus Leibniz, Calculus Feud. After the death of Robert Hooke, Isaac Newton's most significant controversy involved a rivalry with German mathematician Gottfried Wilhelm Leibniz, as both claimed to have independently invented calculus. The debate persisted for decades, with Newton's unpublished work complicating matters. At the urging of fellow mathematician John Wallis, some of Newton's work was released, and he used his position at the Royal Society to challenge Leibniz's accusations. Despite their feud, neither scientist's claims advanced the field, marking this as a regrettable chapter in Newton's life. The passing of Robert Hooke lightened the weight on Isaac Newton's shoulders. Nevertheless, he couldn't evade new disputes. This time, Newton locked horns with German mathematician Gottfried Wilhelm Leibniz over the invention of calculus. Both insisted their work was original, and the other had merely copied theirs. The rivalry transcended their lifetimes, with scholars striving to discern which elements were independently developed and which were borrowed. One complicating factor was Newton's reluctance to publish his work, some of which had been produced during his fruitful years of isolation during the plague. Urged by John Wallis, a fellow Cambridge mathematician, Newton revealed some of his groundbreaking work from the 1660s. Portions of it appeared in his second book, while others were cited in statements issued by the Royal Society, where Newton held considerable influence. He utilized his authority to discredit Leibniz's assertions and label himself the true creator of calculus. But the feud with Leibniz refused to fade. Leibniz openly criticized Newton's inability to explain gravity's cause and mocked his belief in attraction laws functioning within a vacuum. This rivalry haunted Leibniz until his death in 1716, when he bid farewell to the vacuum, the atoms, and the whole philosophy of Newton. In contrast to the rivalry with Hooke, Newton's dispute with Leibniz had no silver lining. The unpleasant chapter in Newton's life did not contribute to scientific advancement, leaving an indelible mark on the renowned physicist's legacy. Newton's legacy and mysteries. Sir Isaac Newton, who passed away on March 31, 1727, left a significant legacy that brought the world out of the Dark Ages. Despite being criticized by poets and romantics like William Blake for turning the world into a dull catalogue of common things, Newton's discoveries remained relevant for centuries. Even Albert Einstein built on the foundation of Newtonian physics in the 20th century. Interestingly, Newton's personal life was filled with secrets, as an exploration of his research in the 1930s revealed his lifelong practice of alchemy and obsession with the occult. In this way, Newton's work shows that he not only valued reason and mathematics but also had an adventurous spirit that pushed him to explore the unknown.
In James Gleick's Isaac Newton, readers are granted an insightful look into the life and relentless pursuit of knowledge by one of history's most influential figures. Newton's intellectual contributions, such as his discoveries in mathematics, optics, and physics, revolutionized our understanding of the universe and laid the groundwork for modern science. Overcoming various personal obstacles, and even intense rivalries, Newton persisted to define essential principles that shape the way we comprehend our world today. As you reach the end of this captivating tale, you may find yourself marveling at the resilient spirit of one man who, in the face of adversity, rewrote the rules of nature and left an indelible mark on the course of human history.